Hello everyone, and welcome to this session about creating your own GKI data source, mostly known as ad hoc data sources. We will, in this session, go over a quick introduction. We will then see on a basic level how to create that data source. We will look into adding a logger and some other basic improvements. We will be looking into taking in user inputs, supporting real-time updates, and then a very short look on accessing data from the DataMiner system in your ad hoc data source. But as a bit of an introduction and also as a bit of an extra announcement is that compared to previously where GKI ran as part of an SL helper process, it is now a DXM, which means that compared to previously where you had to update your whole DataMiner system, which came with downtime and full restarts, the DXM can now be independently updated, which is a much improvement. This also has performance improvements, and the extensions run as separate processes now. It's going to be a lot easier to explain that on the architecture slides. This is mostly unimportant, but these extensions here, which is what the ad hoc data sources are, will be running in separate processes and still run in .NET Framework, while the core process itself runs in .NET 8. So those extensions. Well, we have two types of extensions, which both achieve about the same purpose, but for something different, being allowing users to create their own systems, their own codes to run as part of the GKI system, being ad hoc data sources for data sources and custom operators for operators. Both are created using C#, and they are compiled as part of the automation module, which also is used for automation scripts and such. So why would you extend GKI data sources? Well, we have a couple of inbuilt data sources, being, for example, elements, getting alarms, getting bookings, getting DOM data. But this might not be enough. You might want to access other DataMiner data, you might want to access another database, an API, anything you want. And that's where ad hoc data sources come in. You can access a CSV file, you can access an external API, you can access whatever you want, because it is fully user created. So whatever you can do in C# you can do in an ad hoc data source. So why would you use one? Because for people that have used DataMiner a lot might say, well, we already have a system that allows us to create our own quote-unquote data sources, being the DataMiner connector. And that's correct, but there is a big improvement, well, a big advantage to ad hoc data sources for certain applications, being that it is ad hoc. You might have data that you want to show in your dashboard or your low-code app that you don't want to trend, you don't want to store an alarm for it, you don't want to do much with it, you just want to show it. And that's where the ad hoc data source comes in. It's fully ad hoc. You don't have a database behind it in the terms of a DataMiner. So let us see how we actually create one. What we'll be creating in this session is a view on a map with satellites. The satellites data are going to be gotten from an API, so something that isn't DataMiner, and we will be showing how you get the that API data on GKI and on a map in a dashboard. We also have a package that you can deploy from the catalog. If I show you, I have already deployed this on a DAS. And in this package, you will see that there is an Empower folder, then creating your own GKI data source. And what you will see in here is every step that we'll be going through for creating this one. With each part, you will see here also as a part of reference. So if you want to see how it's done fully, you can see it here. And there's also an extra dashboard that will be going over later. There's also a GitHub repository. I will be writing some codes. And if you're unsure or you want to just copy over some code parts, you can go to that GitHub repository and find all the code that I will be writing today also on there. So let's begin. As prerequisites for creating ad hoc data sources, you technically only need DataMiner Cube. as there is a sort of editor in there, but we highly recommend using Visual Studio together with DIS, or DataMiner Integration Studio, which will it will enhance your ability to create these ad hoc data sources. In the slides, you can find a description on how to do this, but I will show you in Visual Studio itself. So when you are in Visual Studio and you have DIS installed, you will see that if you select DataMiner here in the third dropdown, you have a couple of options for templates. What we're doing today is creating an ad hoc data source, so we can select that one. We can give it a name. I'm just going to do GQI data source satellites. And everything else you can leave. Make sure that this checkbox for the place solution and project in the same directory is not checked. This is not important specifically for this exercise, but if you look into like DataMiner app creation and such, it's important that it's not checked. Then on the second one, you can just fill in your own name as the author. These checkboxes will be going over later, but you can leave them all unchecked now, together with all the other checkboxes here. So let us create it. What you will see is you will get a very basic project with a couple of files in it. The important ones here are the XML file. For anyone who has worked with automation scripts, you might recognize this. It's about the same layout. For ad hoc data sources, this will be a lot less necessary to involve in. You will see that we have some parameters here that say we have to compile it and what the library is called. This is done automatically by the template, so you don't really have to touch this. The only thing that might be interesting is you can provide a folder here. For example, I can just say, I want to place this this ad hoc data source in the GQI folder within DataMiner Cube as a sense for having some organization with your data sources. Then the more important one is this C# file, which has a class in it that's going to be our ad hoc data source. But before we go further with actually creating one, I want to show you how we will be deploying it. You could technically copy this code over to DataMiner Cube and use it there, but of course that's very tedious. So instead we'll be using DIS. What you can do with DIS is you can connect to your DataMiner system and publish ad hoc data sources directly to it without having to do anything yourself. What's necessary for that is in the settings you can add your system here with a username and a password. I have already done this for my DAS system, but in general you can just do add and then username password and you can test the connection here. So in case you haven't done this, you can pause and set up this connection. Once this is done, we can then actually connect to it. This can take some time, but normally this should work. And once it is connected, oh, it was pretty quick now. You will see here that on the XML file, make sure you're on the XML file. On the CS file, you won't see this. On the XML file, you will see here a publish button. And if you hover over this and select the one that you want to use, it will compile this package and upload it directly to your agent. So if we give it some time, you will see that if I now go over to my dashboard and I create a new dashboard here, for example, satellites, and we create this, and then we go into queries, where we find our data sources. You can see here there's a button Get Ad Hoc Data, and here you should see the GQI data source satellites, which is the data source that we just created. If we do this and we drag it here, as a visualization, we see, well, nothing is shown because we haven't put anything in the data source. So let's get to that. But before we do that, the question is, of course, what is an ad hoc data source? Well, an ad hoc data source is going to be a class that you define in your in C#. Each data source has its own class, which then implements interfaces, which will tell GQI what your data source can do and allows it to call the code that you write on the data source. There's different interfaces that you can add. If you looked at the code now, it's going to be a IGQI data source, which is the basic one. But we will add a lot more. Importantly here is that an instance of that clause will be created for each time a user queries that data, which is something you have to keep in mind. It's not like calling the same code every time, it's a new instance every time. And what that data source does is this big thing on the right. This is the full life cycle of a data source, meaning that if the data source is created, users will, GQI will call these methods on the data source. Of course, this is a lot, and it might look a lot very complicated, so I'm going to simplify it to 2 blocks. The 2 blocks are going to be our important part of the data source, being get columns, defining what the columns are of data, and then get next page, which is our actual data, which is the very basic parts of tabled data. The first one, the get columns, will provide us a way to tell GQI, okay, these are the columns that we're going to provide as our data source, what is going to be their type, and how GQI should handle it. I will then show you in code how we actually use this. So as you can see here, we have our class, and we have the IGQI data source interface, which will implement the get columns and the get next page. So firstly, we want to implement the get columns. As you can see on the method implementation, it requires us to give it a GQI column array. So we will just create that. So a GQI column, for some reason it wants to create 5. It's not going to be the case for us. And we can here say that what column is going to be. So our first is going to be a GQI string column. So the type you define here is going to be the type that GQI assumes it to be. So we can say this is a name. This is going to be the name of our satellite. And then aside from the name, we're also going to be providing the latitude and the longitude for the satellite, which is the 2 parts we will provide. So it's going to be a double column, which is going to be our latitude. And then thirdly, we will be providing our longitude, which is very basically saying to GQI, if I provide this array, this is what our data source is going to be. Now to show this off, I can publish again. Normally I should remember what you did last time. So if I now go here and I refresh, you should see that there's still no data, but it now knows, okay, we're going to have a name, a latitude, and a longitude. So let us continue and actually provide some data. That you can do in the GQI page block. This is going to be our actual data. It can be called multiple times when you're using paging. That's why it's called next page. But we won't go deeper into that in this session on paging. So going back to our code, we can go to our next definition, which is going to be our get next page. And this requires a GQI page. As you see here, this GQI page requires an array of GQI rows. But firstly, we actually need to get our data. Now, for this exercise, we are just going to use a package that we created for this demonstration. So using NuGet, you can go to the browse, and if I search for satellite demo, and make sure to use pre-release, you should see that there is a package called satellite demo by Skyline Communication that you can install here. This will just provide us with some API that we can call to actually get the data for the satellites. So once it is installed, if it wants to install, yes, you can just allow it to do this. we should now be able to get the data. So what we can do is we can say, okay, we want to get our satellites, and we can just call this satellite API and get satellites. This will just provide us with an I-read-only list of satellites. But now we get into a second problem, which is we have satellites, but GQI doesn't really understand that. GQI understands GQI rows, GQI cells, GQI pages, but not those satellites. So in general, a good practice to do here is to create a separate method that is going to provide us with a GQI row called createRow. And we provide this with the data that we know comes in from the API, so which is just a satellite. And what this method should do is it should convert data that we don't really know what it is to something that GQI can understand. So if we just say we want to return a GQI row, we can see that if we a new GQI row, we should be able to see using Visual Studio, this will require us to give it an array of cells. So we can create that array. So cells is going to be our new GQI cell array. And we can, of course, define here the 3 cells that we need. Do note that there is no really IntelliSense for this, so you can add more cells, less cells than there are columns. At runtime, you will get an error for this, but at compile time and in the editor, you won't. So make sure that you check that cells are correct and also that they are of the correct type, because here, instead of providing the type here, we just give it a value as a variable, but it does not check the type here. We just say, okay, this is the name, and it's on the developer to make sure that, okay, we said here that the first column is going to be a string, so this should also be a string. Then aside from that, we need to, of course, create 2 more cells for our latitude and longitude. And as part of this API, we need to get that from a method, so the getPositions method, and we then get our position, and we can provide this as the latitudes and the longitudes. So we created now a method. If I add the cells to the row, we have now created a method that takes in a satellite, which is something GQI doesn't understand, converts it to that row that GQI does understand, and so we can use that to convert the satellite data into pages. So what we can do here is just say rows, and using a C# method called select, we can convert that data. Select will just perform an operation on a collection for each part of that collection, and then will give us a new collection with that converted data. So we can just call createRow here. Row, and just convert that to an array, which means that we now went from a I-read-only list of satellites to an array of rows, which we can then provide to the GQI page. You will see that it has another argument here called hasNextPage. This is once again for the paging. If you have paged API data, where you can say, okay, I only want to do first 1,000, you can use this within GQI and tell GQI, okay, is this the last page or not, which will tell the dashboards and low-code apps if it can request more data or not. In this case, it won't really be necessary for us, and the false is also the default for this. But I can go back to the XML, and I can publish this again. And what we should see now, if I go back to the dashboards and I refresh, is that we now have data. Of course, the other thing we can do, aside from showing it in a table, is we can go to the visualizations and show it in a map, which we'll see that we actually have satellite data that shows on the map. And yeah, this is our first data source. it's working. We went from a public API, an external API, to showing that data on a dashboard. But of course, we want to go further. The first thing we're going to look into is using a logger. It's going to be your easiest way to debug what is going wrong, if something is going wrong in your ad hoc data source. Because of course, if you want to go for more complex systems, more complex logic, that will be extremely handy. But to do that, we have to add some more of those blocks, meaning being the onInit and the onDestroy blocks. Do note that both of these can be used independently. They are not required to be used together, but you can both do it. The important one is going to be our onInit. It's going to be the first piece of code that's always going to be executed. And importantly, it provides us with the onInit input args. Why is that important? Because it provides us with two important objects, being our logger, which will allow us to log, and the DMS object, which will allow us to interact with our DataMiner system, which I will show you a bit later. So, but as a bit of a side note, the logging items are going to be provided in this folder. This is for the GQI DXM. For the, if you're still using SL Helper, this is going to be in the log file of the DataMiner system itself. And for the DXM, you can also edit what log level you want to use. But I think it's going to be a lot more interesting if I show you in code how to actually do this. So going to our class, we can just add the GQI onInit interface. And using Visual Studio will tell us, okay, you implemented this interface, but you did not implement the methods. We can just do it using that. Now, for a bit of clarity, I'm going to put this at the top to keep showing what order these pieces of code are going to be executed. So, as I showed in the slides, on the args, we're going to have a logger. But, as you can see, Visual Studio does not think that is the case. Well, why is this? Well, if I go to my NuGet packages and I go to installed, and I remove the filter, you will see that we have this Skyline DataMiner dev automation package, and this will contain all the data, all the types that GQI uses, but it is version 10.3.0.24. This is about the same as just DataMiner version 10.3. When we create the template, we want to use the lowest possible version of DataMiner, of this package, because it has to sort of correlate with the version of DataMiner that you're using. And so this is the lowest possible version that we currently support for ad hoc data sources, but not everything is in there. If you remember the checkboxes from the beginning when we were creating the templates, you could select certain things, and depending on what checkboxes you select, it will increase this version depending on when that checkbox and the interface behind that checkbox was introduced. But we didn't do any, so this is the lowest. Now, for this exercise, I'm using a DAS, which is on the newest version. We can just update the latest stable version, which will provide us with some of the data that we need. So we can just update it. And now, going back here, we should see that we actually have a logger. We can just say, okay, we have a logger here. And then what we can do on the logger is we can just say, I want to log some information. For example, this happens in onInit. Exclamation point. Then lastly, this interface, well, this method from this interface requires us to give back the onInit output arguments, which currently isn't important, so we can just return null. You can also return default if you would want to, but null is just fine. So having done that, we can once again publish, went really quickly there, and go back to our dashboard. And if we now refresh, of course, we assume it's going to still work. No, like I said, the logging is in that folder, and you can find it there. But I'm using a DAS currently, and we currently do not have a way to access the logs that way. We are working on a way to do it in Cube, like you do with the other logging. But for this demonstration, we added this extra dashboard, which will show us the logging in here. And you can see that at about this time, we invoked this GKY satellites and provided that this happened on init. So that logging works. Aside from the on init, we also have the on destroy block, which is a bit of the opposite of the on init and is invoked lastly. And you can use it to clean up some resources and do some other things that are important. In this case, what we're going to do is very simply, we are going to log that the onDestroy is called. Do note, if you're using paging, the onDestroy is only called after you received all the pages. In this case, this is going to be always. So GQI onDestroy. Once again, Visual Studio is our friend, and we can implement the interface. And it should provide us with an onDestroy here. And what we can do is log it here. Of course, to do that, we have to actually get access to that logger. So instead of storing it here in a local variable, I'm going to create a private variable on this class, IGQI logger, going to be our logger. And then we can assign it here, which means that in the onDestroy, we can call information again and say destroyed. And then once again, we can return null. If we publish this again, we should see that going here, going to our satellites view, and then going back to the extension logs, we see that this happened on it and then this happened on destroyed. So both are called immediately after each other. So that is our logger. Now, as part of these two, we have a third block, and this is mostly looking back to that paging and other and generally code readability. Is that we might not want to request our data as part of our get next page. If it's called again and again, we don't want to do the API call again. We want to set it up before. So there's another block called onPrepareFetch, which is going to, if you look at the description, is going to allow us to fetch the data. This will be called before the first get next page, but not every subsequent item. Now, going back to our thing, you might think, well, why not use the onInit for this? Well, the big reason for this is these two lines. The execute path, which is going to be what methods are called when executing the GQI query. Executing here means you open the dashboard, it's on a visualization, and you want to get the data from it. But we also have, for example, the build path. The build path is what happens when you are creating your query. When you add the data source and you want to do subsequent things on it, you need to know what the columns are, you need to know some basic information from that. And onInit is called in both of those cases. So if you would fetch data there, that would be inefficient, and you generally don't want to do this. As you can see, as part of the build path, the onPrepareFetch and the get next page are not called. We also have a third one, which is get columns, but the get columns also follows the same path as the build. So let us implement this into our codes. So going back to our C# file here, we can once again add a new interface, the onPrepareFetch. And using Visual Studio again, we can add that method. I am once again going to place this method before the get next page to visualize what the order is these things are happening. And basically what we want to do here is we want to replace this API call in here to make sure that it happens in this block. We can just once again return null again. But of course, we need access to the satellites here. So under the logger, I can create a new read-only list of satellites, which is going to be our collection and our variable to store those satellites. So we can store them here and then get them in here. Now I can publish this again, but hopefully nothing should have changed. This is purely more of a refactor, but if I go back here, you see that everything still works correctly. Okay, so it's very cool. We added the logger and we added some other things, but we will of course want to go further. Okay, so we have created a decently basic data source. We've added logging. We refactored it a bit to get to the data in a correct way. And now we can go further. Not everyone wants the same data from your data source. You will have dashboards with checkboxes, with drop-downs, and you might want to use that data to fetch different data in your data source. This is where arguments come in. Here, for example, you see this is what we're going to be creating. We're going to allow the data source from the dashboard side to say, okay, I want to get the satellites at this time, compared to currently, which is just going to use the current time. But you can use any data and link any data from your dashboards, allowing you to make something extremely flexible. Once again, looking at the lifecycle, which is going to be a bit of a recurring thing here, we can add two blocks, being the get input arguments and the on arguments processed block. Do note that these two blocks have to always be implemented together. One does not work without the other. You will also get errors if you implement one and not the other. And they are provided from the same interface. And you can kind of see them in the same way we use get columns and get next page. The get input arguments will allow us to provide to GKY what arguments we want the user to fill in. Next to that, we can also say if these inputs are required or not. Then, if all arguments are filled in, maybe they're not filled in, maybe if they are not required, and they're filled in if required, the arguments process block is called, which will allow you to get the data from the argument and then use it later, for example, in your on-prepare fetch, to actually use that data to get to actually use the input argument. So I think I better show you that in code. So going to our class, we can do the same thing we have done for the last 3 blocks, being add another interface. And this is going to be our input arguments. Once again, allowing Visual Studio to help us here, it will provide us with the 2 interfaces. I will once again make sure to put these about at the same place where we would actually call them, which is between onInit and getColumns. And we have our 2 methods. The first one will require us to give back an array of GKY arguments. So what we could do here is just say return GKY argument new GKY. We need to make sure that it's actually new. Okay. And here we can just say GKY date time argument. We want to provide the date. And once again, like with the columns, we will define the type by saying what we're going to put in. And we can provide it with a name, or time. Now, this is correct and this will work, but we actually want to have a reference to this argument for later. So instead of defining it here, I'm going to once again create a new variable, being a GKY datetime argument, which is going to be datetime argument, and just going to place it in here. So it is created before, and then we can just provide it here. And add a comma to satisfy the linter. So this will just provide GKY saying, hey, I want the user to fill in this datetime argument. Then, on the other side, we have our on arguments processed. This will provide us with these on arguments processed input args, where we have a couple of methods, the most important one being our try get argument value. And here you can provide the name of your argument, but it is generally a better idea to provide this with the actual argument, making sure that if you change the name or you change anything, this stays working. Then the second argument is going to be the value that the user put in. So using an out argument, we can, for example, say here, time. But we want to use this data later, so I'm going to once again create a new variable, being a datetime variable, and it's going to be our time. And then in the method, we can directly say, hey, every time you do this, place the argument and the value into that variable. Now, this try get argument value will return true if it got a value, and it will return false if it doesn't. So what we can do here, as a bit of a failsafe, is we can say if we were not able to get the argument, we are just going to say, okay, then we're just going to use the current time. It's just datetime.utc now. Make sure to use UTC now here and not now, because we want to, GQI requires it to the time to be put in as UTC and not normal time. If you were to put in now here, that will actually fail. And then lastly, we can once again provide null as the return value. Okay, we have implemented our two methods, but we currently are not using this time yet. So we can easily go over here, and the reason why this get position as a separate method is because we can provide a time here, which will actually give back the value for it. And that should be everything. So we can once again publish it, showing how easy this is using DIS. And if we go back here, when we go into edit mode, we should see that in the query now, you see that there's now a argument here. And we can, for example, say, I want to know what the data, where the satellites were at midnight 25. And you saw that the satellites changed position. You see that every time you do it, they switch positions. So the argument is now being used to feed and to decide what data you want to fetch from the API, which is extremely powerful. So yeah, this is a very good step. Okay. If you want to earn some Dojo points, you can, if you've been following until now, you can take a screenshot from this showing the datetime argument. And if you're on Dojo itself, you should see the assignment box. If you're on YouTube, you should find it in the description. But if you provide us a screenshot of you having shown the map with the datetime arguments in it, we will give you some Dojo points. But let us continue. A bit of the final part, and one of the funnest parts of the ad hoc data sources, is supporting real-time updates. The reason why you want to do this is currently every time you fetch data, it creates that whole instance. Every time you want to update that data, it has to create that new instance. You have to, for example, put in a refetch or a retrigger on your dashboard, which is generally not very performant, because sometimes you just added or edited one field and you have to fetch all the data again. So real-time updates provides us with a solution for that. Looking back at the life cycle, it will provide us with two more blocks, being the on-start updates and the on-stop updates, once again coming from a single interface. They, as a bit of a side note, but I will show this also as part of the demonstration, is you need to enable updates on a component in the visualization. By default, dashboards and low-code apps will not fetch updates. It is a setting that you have to enable. And you also have to provide IDs to your rows, but I will show both of them as part of the demonstration. Looking at the two blocks, the first one is going to be called between the onPrepare fetch and the get next page. If updates are enabled, and will allow you to set up, for example, subscriptions, timers, whatever you want to handle those updates. It also provides the updater object, which will allow us to actually edit data within GQI. We also have the on-stop updates, which is called before the on-destroy, but only if on-start updates is called. So make sure that this only gets used to destroy destroy things in your class if updates are enabled. So let me show you that. So back on our code, I'm going to quickly remove our input arguments. Technically, you can very much use them together. For our exercise, we're not going to, because the part of what we want to update here is the latitude and the longitudes, and we're going to do that by updating on time. So having a time input and having real-time updates on time doesn't make very much sense. So I can just remove part of our code. And instead of the on-input argument, we just can say here GQI updatable, which is going to be our interface for real-time updates. Once again, using DataMiner Visual Studio to help us here, we can see that we got our 2 blocks here. For the first one, we firstly want to store this updater in a variable. I'm just going to do this down here. It's not the best code practice, but it's for demonstration purposes. I can just store the updater here, and this is going to be our updater, because we want to use this later. And then we can just assign this here. Then the next thing we want to do is set up the updating itself. For this, I'm going to use an object that we provided as part of the API, which is trigger. This is just an implementation of a timer that performs an action every second. So we actually want to perform something, so we actually have to implement that. So going here and priv update. This is the method that we want to call every time that second ticks, or whatever other trigger you want to use. And we want to update our data here. Now I will start here by writing a try-catch. For the other ones, they are called through GQI, and they are try-catched, but this one is a bit more scary in this case because it's a callback from a timer. And so if there would be exceptions in here, you might have more trouble. So I'm just going to quickly set up a bit of a try-catch to make sure that issues in this update logic do not crash anything. So, and here I can, for example, issue in updating. It's generally a good idea to log exceptions that you catch, so in the future you can avoid them. But what do we want to do here? Well, very simply, we want to loop over every row in our satellites. So for every satellite, we want to perform something. What do we want to do? Well, we want to, once again, I'm just going to call this satellites for better readability. We want to, once again, create a row. Remember that in create row, we're going to call position, which uses the current time. So every time this is called, it's going to create, well, the new row with the latitude and longitude of that current moment. And then we can just say updater dot update row. It's as simple as that. Now, as part of our implementation here, we want to actually update it. I should make sure that I'm actually creating a new instance of this. And for good practice, I'm going to store this also in a separate variable and show it here. Why do I do this? Well, to make sure that everything is disposed correctly in the on-stop updates, I'm going to dispose this again, making sure that once the client says, okay, we don't need this data anymore, the timer is cleared up and we're not performing any code anymore. And well, that should be everything. except for those two items I said before the updates that we need to watch out for. The first one is to do with IDs. If you want to say update this row, GQI of course needs to know what is that row. So as part of the GQI row constructor, we can provide here next to the cells, we can provide a ID or a key. In this case, I'm just going to do satellite.name, as that one will be unique towards our satellites. So having implemented that, I can once again publish. And here, if I refresh, you will see that the argument there will be no arguments once again. And well, on the map, it's a bit hard to see. But if I go to the table, you'll also see that they are not updating. Why is that? Well, as I said, we have to enable this on every visualization. So normally, if I update the data here, you should see that every second the position is updated. Going back to the map, we might be able to see, if I, for example, zoom in on one of these, it's going to be a bit hard to see them actually moving. But compared to what you would otherwise do, for example, putting a trigger on this component and saying, okay, every second we're going to refetch all the data, we are pushing data from GQI and saying, okay, this is the new data, this is the new data, making it a lot more efficient. So yeah, that's real-time updates, which is going to be one of our last items. There's a short segment here that you can, that a bit of information on the connecting to your DataMiner system. As I said in the part about the logger, on that, on input arguments, on init arguments, you will also find a DMS object, which you then can use to send SLNet messages, make subscriptions, and do pretty much anything you want with your DataMiner system. There's some information here. And to close it off, I want to highlight some practices, good best practices when creating ad hoc data sources. One of the big ones is using the DIS template. It will make sure that everything is set up correctly. You can publish it, you can create DataMiner apps. It's going to be a lot easier to do compared to other options. You can, because everything is GQI, is C#, you can look into caching, be it on files, static memory, or anything. It makes sure that every time someone, for example, refreshes their dashboards or does anything else, it doesn't have to go, for example, do an expensive API call. You can use pacing when possible. It's a lot better to request 1,000 rows from an API compared to 1,000,000, for example. So, and GQI allows you to implement that. Next to that, real-time updates are also highly recommended. Refetching the data every time is a lot more expensive, computational-wise and API-wise, compared to only changing data when it changes and pushing that data. And you can also define multiple classes within one library, which will ensure that everything is, which will make sure that you can use certain codes next to each other, and DIS, when you publish it, when you compile it, will actually handle that very well. So yeah, I hope you enjoyed this session. I hope you learned something, and I'll see you in the next one.